Good morning. I'm going to record a few tutorials for solving the problems on the practice test. This tutorial is going to cover problems 1, 2, and 3 because in those problems we're already at equilibrium. And what that means is if you're told that a problem is at equilibrium, you don't have to set up an ICE table. We can just figure out what the equilibrium expression is, plug in the values we're given, and solve for whatever we're missing. So on the first problem, you'll notice that we're starting with this equation, sulfur trioxide plus water is in equilibrium with sulfuric acid. These are all gases, so they will, well, actually this one is aqueous, sorry. But that means that they will all be a part of the equilibrium expression. So our equilibrium expression is the concentration of our products, which in this case is H2SO4. So that'll go on top. And then we're going to divide that by the concentration of the product of our reactants. Now in this case, we don't have any coefficients, so we don't have to raise anything to a power. And all we have to do is asking for the value of equilibrium. All we have to do is plug in those equilibrium concentrations that were provided. For H2SO4, we're told that the equilibrium concentration is 0.600 molar. For the sulfur trioxide, it's 0.200 molar. And for the water, it's 0.350 molar. So when I plug those in, 0.6 divided by 0.2 divided by 0.35, I get a constant equilibrium value of 8.57. I had 3 sig figs, so I just kept that in my answer. The second question throws in a little wrinkle. It says at equilibrium, a 4-liter flask contains 0.1 molar PCl5, 0.2 molar water, 1.25 molar hydrochloric acid, and 1.250 molar of p-oxygen chloride 3 chlorides, POCl3. So once again, I want to start by writing my equation and setting up my equilibrium constant. So this time my equation is PCl5, which is a solid, that's going to be important, plus H2O, which is a gas, is in equilibrium with hydrochloric acid and this gas, which I'm not sure what the name of it is, POCl3. Now, like I said, the first thing I want to do is set up my equilibrium constant, which in this case is going to be my products. And of course, because I have a 2 for the hydrochloric acid, I'll have to square this one. So we always put the products on top, the reactants on bottom. Notice though that I am not going to include PCl5 because it is a solid. I'm just going to have to worry about the water. So the next thing I need to do is take a second and figure out what my concentrations are. Remember, concentrations are typically given in moles per liter. And so we are told that we have 0.1 mole of this, but not worried about that because it is a solid. I have 0.200 moles of water, 1.250 moles of hydrochloric acid, and 1.250 moles of this other gas. Now they're telling me that this is in a 4-liter flask. So that means in order to get molarity, I'm simply going to divide each of these by 4 liters. so that my concentration of water, 0.2 divided by 4, is going to be 0.0500 molar. And my hydrochloric acid in POCl3, 1.25 divided by 4, so there are my concentrations that I can plug in. So when I plug those into my equilibrium expression, see, 0.313 times 0.313 times 0.313 divided by 0.05, my equilibrium expression comes out to be 0.613. Hopefully that's right. Okay, so the third problem is our last one that is super simple. And by super simple, I just mean it's already at equilibrium. So our third problem says this: 0.75 moles of sulfur dioxide and 0.750 moles of oxygen are found in a 2-liter container at equilibrium. If the equilibrium constant is 1.10, what is the concentration of the sulfur trioxide? So let's start by writing down our equation. And our equilibrium expression. So this, once again, our products are on top. And we're going to raise those to the power of their coefficient. My products are on bottom. Raised to the power of their coefficient. Next, we are going to figure out what our molarity is of the ones we have, so that we can solve for the ones we don't have. Just as a reminder, they've told us that this is equal to 1.10. So we are told that we have 0.750 moles of SO2 and 0.750 moles of oxygen. And they're in a 2-liter container. So that we know that these are going to be equal to 0.375 molar. I believe that's 0.750 divided by 2. Yep. So now I know this one, and I'm just solving for this one. So what I'm going to do is I'm going to plug this in. And I'm going to put these others on the bottom. So 0.375 squared times 0.375. And of course, I know this is equal to 1.10. So now when I solve it, I'm going to take 1.1 times 0.375 times 0.375. And I find out, as I simplify this, that the concentration of SO3 squared is going to be equal to 0.0580. If I take the square root of both sides, so the square root of that number is 0.24. Well, 0.241 actually. So one last thing we can do is we can plug these values back in to see if they work. So I'm going to take this number squared divided by these and see if I get 1.1. So 0.241 times 0.241 divided by 0.375 3 times And I get 1.10. Bam, got it. Anyways, that's the first three problems. I hope that has helped you. I'm going to end this so that people do not have to watch this one if they want help with another. So hopefully that was helpful.